Okay, so what happens here that if you multiply this value of the 72 gram of the original ketone with this value, the percentage, which is actually the increased value, you get 1.6744. This 1.6744 must be added into the original 72 value of the ketone, you get 73.67. This 73.67 is not equivalent to the 74, which I told you before that it should be an increase of 2 units because only 2 hydrogens were added. So the change is from 72 to 73.67, not 72. What I'm saying, 72 to 74 must be the whereas in our calculation 72 change into 73.67, which is not correct, which means we need to modify the change in the structure of the ketone we took. So I'm going to add an additional carbon atom or chain in the original ketone. When I do this, I will do the same reaction with NaBH4. When it is reacted with NaBH4, you get again an alcohol, but it must have an additional carbon atom. Now we need to again do the calculations of additions and the percentage increase of the molecular mass. For this carbon, you should know that I have just added an additional CH2 group here, which means you can add 14 because the value of CH2 mass is 14. So when you add 14 into it, it gives you 86. So 86 was the mass of this original ketone, and after having reduced, the mass should become 88 because there is only a change in the additional 2 hydrogen atoms, one from the OH and one from the carbon bonded with the C, the alcohol part. So there is a change in the this. Now we have to calculate the gain, whether there is a change of 2 or not. So what I'm going to do, I'm doing the calculations here. I will take again 2.3256% multiply by the MR of the original ketone, which is 86, and this will give you 2.4016, which is you can consider as equivalent to 2. So 86 plus 2 will give you 88, and that's the right answer, 88. So yes, the change is there of 2.32% when the original ketone had this structure. So I'm using this structure of the ketone, 86 to 88. Now, which means that our original ketone has been considered as the right one. Now we have to find how many isomeric ketones could be ketone X. So this ketone must be shown in terms of the number of isomers this ketone has. Okay, so for this purpose I need to erase some of the part of my calculations. This means if I select this part of the ketone, then I have these isomers of the ketone. I have this first part because this is the original ketone, and I can draw another isomer of this compound by slightly changing the structure of the second carbon. Here this is the isomer, and I still have that part which is required for the iodoform test. So this is the second isomer. But if I try to put the carbonyl on the third carbon, then this third carbon will not give me the iodoform test. It is not possible because it does not have that part required for the iodoform test. So this cannot be the isomer, which means how many isomers do I have? I have only 2 isomers, this isomer and this second one, which is just this one near it, this one. I can show you a proper working to make all this fuss away. Okay, so here's the actual working, another working of the same question. Even I have shown you how the ketone was showing a change from 86 to 88 with the percentage value of 2.3256, and then I am showing the isomers. This is the first isomer, this is the second isomer, and this isomer is not possible because it cannot show me the iodoform test, for which I need this part, or another way I need this part to give me the iodoform test, which is not present in this structure. So there are only two isomers. Now the next question, for this question I need to remove some of the working of the previous question. All right, this next question, compound Y changes the color of the acidified potassium dichromate from orange to green. It has no effect on phalanx reagent, and it produces an orange precipitate with 2,4-dinitrophenyl hydrazine reagent. What is compound Y? Okay, we have four different compounds, and we need to check all these 3 points on each and every compound. If you recall from your literature which tests are getting from which compound, that must be noted. The first point I'm going to write first point, second point, and this is the third point. The compound which can give me the first point or the first test is the alcohol, because it can be oxidized, and in that case the color will change from orange to green, and alcohol can give me this test, and the aldehyde can give me this test because aldehyde can convert into the ketone. Now about the second point. The second point means it has no effect on the phalanx reagent. You should remember that phalanx reagent can only be given by the aldehyde. In other words, I can say that which compound cannot give me this test is the ketone, RCOR. It can be the carboxylic acid or ester, and it can also be the alcohol. These compounds cannot give me this test. And about third point, which a compound can give me precipitate 2,4-dinitrophenyl hydrazine 2,4-DNPH. Both the aldehyde and the ketone can give me this test. So all these can give me the test. So considering these 3 points, I need to see which is possible and which is not. Let's check option A. Option A has the aldehyde group and it has the ketone group. So what I see that the second point, which is the no effect on the phalanx reagent, no effect on the phalanx reagent, which means it should have ketone, it should have either carboxylic and alcohol, but it has an aldehyde group here. Aldehyde group can give me the phalanx reagent test, which means point number 2 is not applicable on it. It has an aldehyde group, which should not be here. Now check compound B. Compound B has the ketone group and another ketone group. Both the groups are ketonic. Now on this structure B, the point number 1 is not possible, because point number 1 states that it should show the oxidation using the K2Cr2O7, but ketone cannot give me the oxidation by using this compound, which means point number 1 is not applicable. Now for the option D, this compound has alcoholic group over here and alcoholic group over here. Now on this compound, option number 3 is not possible, because option number 3 said it should show the positive test with 2,4-DNPH, which is not possible with the alcoholic, so it is incorrect. But option C has alcohol and a ketone group, so we can say that alcohol is present in point number 1, alcohol is present in point number 2, as well as ketone is also present here, and in point number 3 the ketone is present, which means all the 3 points are applicable on the C part. All 1, 2 and 3 are applicable on compound C, or option C is the right one. Then question number 36 is already solved, so we don't need to do this question. It is already shown, and you can see that it is taken from May, June and 2003, and then October, November 2008, which means the questions were very from very old past papers. It means you will need to keep practicing the old past paper in terms of the organic questions. Then question number 37. Question number 37 says P is a carboxylic acid with molecular formula C5H10O2. Carboxylic acid P reacts with an excess of lithium aluminum hydride to form compound Q. Which pair of the compound can be carboxylic acid and the compound Q? Okay, so here we have the carboxylic acids in the first column, and it has been reacted with the lithium aluminum hydride, which is lithium aluminum tetrahydride, which is basically a reducing agent, which means after reaction with this compound it should give me the reduced form of the carboxylic acid, and the reduced form of the carboxylic acid can either be aldehyde or it can further be reduced into alcohol. So let's see which possible structures are there. The first point says that it has carboxylic acid with 5 carbon atoms, and it has carboxylic acid group here. It is converted into alcoholic. That's all right, but how about the number of carbon atoms? There should be 5 carbon atoms, 1, 3 and 1, 5. Over here we have 1, we have 3 carbon atoms. These give you 4, so that's incorrect. Number 2, it says that the carboxylic group is converted into aldehyde. That's all right. What about the number of carbon atoms? 1, 3 and 1, 5. In the product there is 1 and there is 3. Again you don't have equal number 3, and yes, we have 4. We do have the we do have the 5 carbon atoms here again, but the problem is that it should not give me the aldehyde group, because the compound P is reacted with an excess. It means there is a mistake here. It doesn't mean it should give me the aldehyde, it means it should only give me the alcohol. When excess amount of the agent is used, it should give me the alcohol, and that's why this answer become incorrect, because it has an aldehyde over here. This is incorrect. And for 3 compound, we have how many carbon atoms? We have 3, 4 and 5 carbon atoms, and in the product form we again have the 5 carbon atoms, 3, 4 and 5, whereas the carboxylic group is converted into the alcoholic group, and all the rest is fine and it's all right, which means this is the right answer. Carboxylic group should be converted into the alcoholic part, so the third option is the right one. And from the given options of A, B, C, D, the right option becomes D, because it is the only product obtained as a result of this reaction. Now question number 38. Compound X is treated with an excess of dilute aqueous potassium hydroxide. What is the structure of the organic compound? Okay, so in this question basically we are given an ester compound here, an ester. This is a part of an ester, and when it is reacted with the dilute aqueous potassium hydroxide, when an ester we react with this compound, you get the hydrolysis reaction, and as a result you get an alcoholic part plus the ion of the carboxylate group. You get an ion of the carboxylic group, R(C)R. But if you had HCl, then you would, and any acid, let's suppose, then you would have gotten alcohol plus the carboxylic acid, but this time you have a base, or you have an alkali instead of an acid, so that's why you will get alcohol plus carboxylate ion. Okay, now let's check here. Number one, we will not get the carboxylic acid, that's incorrect. You will get the carboxylate ion, but we need to check whether is it right or wrong. Okay, the reaction will break it apart, the X compound will break apart from this point, because this is where the hydrolysis occurs, and this part becomes the alcoholic and this part becomes the carboxylate. So you will have oxygen 2 over here, and OH group will be bonded with this single bonded oxygen, so this will become the alcoholic. So we have to count the carbon and the branching on it. If it is 1, this is 2, this is 3, this is 4, and this is 5. So this is 1, this is wrong answer. This is 1, 2, 3, this is 1, 2, 3. So on carbon number 3 we have a methyl group, so we do not have methyl group carbon number 2, so this becomes incorrect. We do have a methyl group carbon number 3, and because of these two reasons it is the right answer. The third methyl group on carbon number 3 was also present in option B, but it does not have the carboxylic acid group. So because of these two reasons, it is correct, this is correct, the ion is correct, and this methyl group is correct. So for this reason, the option A is the right one. Now the next question, 39 is already solved, so let's skip this question by me. You can get the answer from the description. Now the last question of this paper, question number 40. Question number 40 is again quite tricky and it takes time to solve. Okay, the question says the relative atomic mass of antimony is 121.76. Antimony has 2 isotopes. The mass number of the 2 isotopes differ by 2. The isotope with the lower mass number is more abundant. What is the percentage abundance of the isotope with the higher mass number? Okay, I can again guess that this question is that much tricky that it will be included in the exam report, which is yet not published. So I hope this question will be included in the exam report. Now what happens? How can we solve this question? In this question you should remember the formula or finding the relative atomic mass, which includes isotopes and their masses, abundances, and their masses. Let's suppose for this relative atomic mass, there are 2 isotopes. I will write first isotope as Sb1. Sb is the symbol of antimony. Sb1 with its relative abundance or its abundance. We write as relative abundance of Sb1 plus second isotope with its relative abundance, and they are multiplied with each other divided by 100. This gives the value of relative atomic mass. Over here this is the value of AR. We already provided this value, but you know that in this question we are not provided with any percentage values and neither the actual mass numbers. So neither the mass numbers are there nor their abundances. Then it becomes difficult to find the relative atomic mass. Even if we had only the percentages of both and mass number of only one isotope, we could get the answer. Or in other way around, if we had the mass number of both and percentage only one atom, we could easily find. But how can we do in this case? In this case we need to see this value. This value means the relative abundance must be somewhere in between 120 to 123. The value of the mass numbers of both isotopes Sb1 and Sb2 must have their mass number in between these 120 to 123. Now how can we check it? We need to do some approximation. First of all, they are saying that there are 2 isotopes and the isotope, this is the isotope first and this is the isotope second, and I say that this is the order in terms of their masses. I am saying that Sb1 is a smaller isotope and Sb2 the heavier isotope. Then they also saying about the abundance. They say that Sb1 has a greater abundance than Sb2. According to the statement, the isotope with smaller mass has greater abundance. That's the other information. Now, if considering these 2 points, if I say that if second isotope, which is a heavier one, has these 2 percentages, which are given the option 62% or 88%, it means that the percentages of the first isotope will either become 38% or 12%. That is not possible. That is not possible because they are saying that the isotope with a smaller mass, Sb1 is smaller isotope or lighter isotope, it must have a greater abundance. That is not possible here. It cannot have smaller percentage than the other isotope, so option both C and D become incorrect. Now let's do the calculation on the option A and B. Okay, I'm going to choose the range of 120 to 123, and they are saying that their masses are changing by a unit of 2. There is a difference of 2. So let's take from 120 up to 122. So that's the masses difference. I'm doing the calculations here according to this formula. I will just do the partial calculation. I know that I will take Sb1 as first isotope, so I'm assigning it as the value of 120. This is the Sb1, and I'm taking its percentage as 88%. If I take its value as 88%, then the other isotope, which is heavier, must be 2 units greater, and its percentage will be 100 minus 88. 100 minus 88 gives me 12%. So its percentage, heavier isotope has smaller percentage. Now the value will be 120.24. This 120.24 is the relative atomic mass which is obtained by this calculation, and it does not reflect this value 121.76, so this becomes incorrect. Now I'm going to change the percentage value of the lower isotope. In this case, I will select the lower isotope with the 62%. 120 times 62%. Why 62%? Because I will select 38 as for the heavier isotope. Now 62% for the lighter isotope plus for the heavier isotope I will assign 38%, and this will give me the value of 120.76. This 120.76 is very much similar to the 121.76, which means I'm just 1 unit away from the actual answer. So I can say that I will select 121 as a smaller isotope with its heavier percentage, and 123 as a heavier isotope with 38% abundance, and in this case I will get the answer 121.76, and that's the right value of the relative atomic mass. And that's why what they say is that which percentage abundance answer with heavier mass, with the higher mass number must have the smaller abundance, which I took over here 38% as for the higher mass number, and this is the B option. That's why B is the right answer. And that's how I have completely solved this first variant paper 1 of May-June 2024, and I hope almost all the students must have benefited and got the actual concept of attempting this paper. So with this, I will end this video, and if you have any queries, do let me know in the comment section or reach me out on my WhatsApp number. I will try to make videos on your demanded questions, and again I will ask you a small favor to do like this video, watch it completely, and share with the other students in your circle and the other persons associated with the academia, especially the teachers. And do subscribe my channel, and also ask others to subscribe my channel. I will inshallah come again with another video. So till then, take care and Allah Hafiz and good evening.